Hey everyone, I'm Ty Smith. I work at Twitter. In 2013, we started a project at Twitter to bring all of the SDKs that we had under one roof, an umbrella of product for our developers. We call that Project Fabric, and today I'm going to be giving you guys some tips and tricks on what we learned from building that, and then how you could use those to build your own SDKs, libraries, or even make better applications. So what is Fabric exactly? Well, it's a set of modular SDKs that share a common platform, so we have a reduced footprint in an app for an application that a developer may use this in. We released it last year in the fall, and best of all, it's free for everyone to use. We believe it's a great way to bootstrap your mobile apps. As we were building Fabric, we kept several goals in mind that helped guide us as developers. We think that these ideals they're great to use for your own applications or any SDK that you're going to be using as well. So I'll walk you through those today. We currently offer 7 SDKs that are all make up Fabric. We call these kits. They're logically grouped artifacts that we distribute. It can be one or more artifact, and on Android we bundle these as AARs. The Crashlytics team had a huge influence on Fabric as we were building it out, and so that's a large part of what we offer as well. The kits that we launched with include crash reporting, analytics, beta distribution, sign in with Twitter, embedded tweets, sign in with your phone number, which is white labeled, and our advertising exchange. Fabric is much more than just a set of SDKs, though. It deeply integrates into your development flow. We integrate with all major IDEs and on iOS for Xcode. And we also integrate into the build tools like Ant, Maven, and Gradle, so you can quickly onboard new applications, inject code needed to get started really quickly, provision your app keys, and then provide dashboard functionality for your SDKs. Part of our platform is providing a consistent backend experience. We offer dashboards for all of our products, so we can monitor and interact directly with the SDK. Here's an example using our Answers Kit, which is our analytics service, so we can observe stability over time for an application. To help get app developers started with Fabric, we created an open source game that we call Cannonball. It's a social magnetic poetry game. You guys can get this on the Play Store today, and you can also check out the source code at github.com/twitterdev. Perfect. Now that you have an idea of what we've been building for you, let's talk through the learnings that we had from Fabric and talk about how you can apply those. So before we start showing code, we need to think about some considerations that you want to think about before you start building a library or an SDK. First is, what need are you actually serving here? Are you building this for your internal developers, for another team at your company, or is this for public developers? Who's going to be using this, and what value are you adding? I think Jake and Jesse talked a lot earlier about don't just build another JSON library. I think this is really what I'm trying to get at here, is really figure out the need you're serving before you decide to move forward with this. Next is you need to think about how you deliver your project. On Android, there are really 4 major ways that you could deliver a product for an app developer to consume. The first is a standalone library project. This is the oldest and kind of the most straightforward solution. It involves just having your source code available on GitHub or elsewhere, and the app developer checking that out directly into their project, marking it as a library project in Android Studio or in Eclipse, and using that. But it has a lot of problems as well. How does an app developer stay up on your updates? What if they fork it and cause problems? How would you know as the SDK developer what's going on here? The next are jars, which are a great option. They're really old, come from the Java world, pretty standard. However, in Android, you'd be limited in that you can't have views in your jars. So if you're doing any sort of view-related library, that could be problematic. APK libs were kind of a community-introduced solution to this project when Maven was starting to come out as a big build tool for Android. And it is just a zipped up version of a library project. I wouldn't necessarily recommend using this because it's not the standard approach. AARs have pretty much replaced this, and you're not going to get great support in the tooling going forward. That brings us to AARs, which are the current recommended approach by Google. It's a zipped container that includes the compiled class files as well as the resources. You can use this for view-related libraries or anything else. One of the downsides to AARs is that currently Eclipse doesn't support it yet. The Fabric team, though, we chose to use AARs regardless of the Eclipse support, and our tooling that I talked about earlier actually handles this for the user. We have our plugin that uses Ivy internally to resolve to our Maven repository, pulls down the AAR, unzips it, and then injects it into the workspace as a library project. This is a little a lot of overhead, but as the Android community moves forward, Eclipse will be less of an issue, I think. Another consideration you need to make when you're building an SDK or a library is it doesn't necessarily have to be open sourced, although most people would prefer it would be, and I love open source. But you also need to consider that you may have business requirements that lead you to a closed source solution, and what is the associated licensing that you need to consider if you are open sourcing it. Some things that you might consider for keeping a closed source library are what sort of backend requirements do you have, where is the value in your product? Is it an SDK for business logic, or is it an SDK just as a utility? When you're talking about licensing, a lot of people need to be wary of GPL licenses. A more flexible license that I'd recommend is either MIT or Apache 2. This is something that you'd probably, especially if you're in a bigger company, you need to talk out with your legal department. The last consideration you need to make is where you're going to be hosting these artifacts. If you're open source the library, then it's great. You can put it on Maven Central or JCenter, and most of the standard tooling resolves this out of the box. But if you're having a closed source SDK, then you can't put it on Maven Central or IntelliJ, so the user's going to have to put a custom Maven repository in their build script. So that's something extra that you'll have to communicate to the users of your library. All right, you figured out your product strategy. Let's talk about the two qualities that we really focus on for Fabric, and that's being powerful and lightweight. The first goal we aimed at was building a powerful SDK. To us, some of the things that make an SDK powerful are its ease of integrating the SDK into an application, the extensibility of the API, handling failure gracefully, and runtime detection for flexibility. When anyone sets out to build something, they don't, even if it's for their own consumption, they don't think to themselves that they want to make it complicated. It just usually happens over time. They didn't try to have a constructor that took 15 parameters and 0 documentation, or the opposite, 10 pages of documentation that takes forever to read and is extremely verbose and hard to understand. But these sort of things happen, and it makes using SDKs or open source libraries or even parts of your own application really hard to use. So our first goal with Fabric was to create an SDK that was pretty easy to use. We wanted to create the easiest way possible for developers to get started, and it doesn't get a lot easier than this. We just use one line to initialize Fabric and get started. But we require different dependencies, right? And so one example is that we require an API key with Fabric so that it can interact with our backend service and be provisioned appropriately. So because we have, there we go, that's much louder. Thanks, guys. I'll just start over. So we have a backend service for Fabric. That's a big part of the offering. And we needed an API key so that we can provision and we can have, detect unique users and accounts and everything else. But we didn't necessarily want to require this API key be injected at the very beginning by the developer and add that extra overhead. So we try to detect the dependencies when we can. We use our plugins and our onboarding tools to inject the API key into the manifest, where we can use the context to resolve that at the beginning of the initialization with Fabric. We do also, by the way, if you have an open source library and you don't want to include your API key, we do have some alternate approaches, like it can be through a properties file. And that way you could add that to your git ignore. It's trying to be a little bit flexible. But once we've started this initialization process, we can use the package manager. We can read the manifest. We can grab that API key out, and then we'll be good to go to start making our network requests. As you can see in the initialization process of Fabric, it only captures the application context. This is important because if we were capturing the activity and holding onto that in a static instance, Fabric is stateful. It lives statically across your entire application. If we were holding onto that activity, we could potentially cause memory leaks. So we're holding onto the application context, and when we do use the activity context, we reference it to avoid those sort of memory leaks. This is another example of getting dependencies when we need them, but taking a little bit of flexibility. So part of Fabric is the Twitter API client. It's the client you can use to make authenticated requests to the Twitter endpoints. You can do things like embed tweets, or you can just create content on the Twitter backend service. So what do we do here? We take an authenticated session as a constructor so that you can manage multiple sessions yourself. You could have flexibility for multiple accounts. But in the event that you don't want to manage that yourself, our empty constructor goes after our session manager, and we try to get the active session from that. So this is a great piece that shows the flexibility that we provide, where in one case, it's a building block for developers. They can use it very explicitly. And in another case, for someone who just wants to get up and be using it a little bit quicker, we provide the session management under the hood for them. Hopefully some of you will say, hey, why don't you use a dependency injection framework? This would simplify this sort of thing a lot. And I would say I would love to. And we do use dependency injection as a design pattern, but using a framework like Dagger becomes problematic when you're writing SDKs and libraries because it adds extra overhead, and it kind of goes against the second quality we're going to be talking about later, which is being lightweight. Another thing that's really important to us is that our SDKs are really modular and extensible. I was happy that Jake and Jesse called this out a little bit earlier. It's super important. So when we introduce the concepts of kits or these functional units that developers can add only one piece, and they don't necessarily need to add the entire set of fabric, which would be a lot of overhead. But once they had these small pieces in, we needed them to be very extensible so they could easily update and add new features. Even with the Twitter API client, we don't provide all of the API endpoints. By having an extensible API, we allow the developers to use the authenticated logic that we have and scale that out pretty simply. And I'll dive into that a little bit more in a minute. Existing users of Crashlytics, you guys will recognize this first line. And if you were a power user, you might recognize the other 3 lines. We had these extra setters, and they were all added over time and by different people in different styles. And just at a first glance, you can tell that there wasn't a lot of consistency with the style that we were going after here. These are things like adding, a custom SSL pen or setting a listener for when a crash happened. You can do some simple stuff like that, which is powerful and needed. But when you're looking at this, it really wouldn't be clear to you when you needed to set this stuff up before Crashlytics ran, and because Crashlytics is installing an uncaught exception handler, you don't know when it's ready to use. So unless you really read the Java doc, you wouldn't be clear on the proper uses of these. They're actually supposed to be called before Crashlytics has started, so that when it starts making its first network requests and setting up the uncaught exception handler, it has that information ready to go. So when we started building out Fabric, we tried to make this better. If we needed these parameters to be called before start, why didn't we just add them to our initialization call? And then as we add more functionality, we can keep tacking on parameters. Everyone loves passing around a series of nulls or meaningless integers. We thought there had to be a better way. And so what did we do? We decided to utilize the builder pattern, where you can specify additional optional parameters for each kit. But this pattern helps alleviate the burden of having these methods or constructors with too many inputs. So what we do here is we take all the optional parameters, and we guarantee when we construct the object that it's in an immutable state so that they're thread safe, and that we have all the defaults that we need. We also made use of this builder pattern in Fabric itself. So we allowed the developer to set all kinds of complex, additional settings on Fabric if they wanted to set their own logger. We add that. If they want to set their own custom executor service, if they want to turn on debugger mode, we allow all that through the builder pattern as well. Part of making extensible code is allowing the developer to choose to be notified when certain behavior happens. So here's an example of initializing Fabric with a listener for when the initialization is done. We do both synchronous and asynchronous initialization with Fabric in all of the kits. And for some developers, it's important to know when everything is completed so that they can continue. And so by using the builder on the previous screen, a developer can set this initialization callback, and then they can be notified when this is done. Developers have quite a range of tools, and therefore they need a lot of flexibility in their code. We provide extensible interfaces to try to help with this. One example is logging. Like Jake called out earlier, there are many different logging frameworks, and they handle different things in all kinds of different ways, and a lot of them try to have cross-compatibility with other logging interfaces. Well, what we do is we provide just one simple interface and then a default implementation of this interface. So if you were using something like Timber or Log4j or whatever logging interface you wanted to use instead of Logcat, you could quickly implement your own version of this interface and call through to your own logger and hand this to Fabric, and then we would respect this through the entire set of the SDK logs. Here's an implementation of our default when that isn't passed in by the developer. We just default to Logcat, which we believe is the same default using the Android logger. Another great example from Fabric is the API client that I called out earlier. We have some of our most popular Twitter endpoints defined already in Fabric, but if you've ever worked on any Twitter products and looked at the REST API documentation, there's hundreds of endpoints. Most of them are never used. You wouldn't need to use them except for very specific use cases, and we didn't want to maintain an SDK with hundreds of unused methods, so we chose only to provide the most popular ones. But then we made our API client extensible, so that a developer can extend it, create their own custom API client, and then provide their own retrofit style interfaces to hit the endpoint that they need. More than just code, though, we believe it's good practice for extensibility to apply to views as well. So what we do here is we allow our embedded tweets or login button, different UI elements that we provide through our SDK to be themable. So you can do this through styles. One important thing to note, though, is that DEX merging doesn't namespace for libraries. So you can have conflicts. You could have unintentional overrides where you defined something that was very generic, like maybe you had a button and its background color was just color.background. Developer in their application probably has something defined as background as well. They're going to override you unintentionally. So we namespace everything so that we don't have these unintentional overrides. And if the developer does want to intentionally theme it, they can define the namespace that matches ours. Aside from implementation details that we just talked about when designing your API, we generally think about a few traits. The first is being intuitive. An API should act the way the developer expects without having to reference the documentation. Your SDK should be consistent, especially the naming. So name your methods in a similar fashion across your entire library, SDK, application, whatever. Use common language. Don't name the success method for network callback success and success for a database operation on success. An API should be easy to use and hard to misuse. Validate your inputs. Have sane defaults. Make the developer feel safe and feel like they have an understanding of what's going on just by looking at the code without documentation. Let's talk about handling failure, because developers are impatient and inquisitive, and the faster something fails, the better. And I'm sure if you've been using Gradle, you'll know what I'm talking about after it's been building for 5 minutes and then fails, and you feel like you have wasted time. You should throw expected exceptions so that the developer knows there's a problem quickly and it can be addressed when it's appropriate. So you wouldn't want to fail in production. This sort of failure needs to happen during the development cycle so that they know immediately they lacked a dependency, they passed a null in, it can be addressed. But you should really try to catch all exceptions and only do that intentionally in development mode. A developer's app is often their livelihood, and so if you're an SDK that's crashing, they're not going to bat an eye at replacing you with something that is a little more stable. So I'd recommend gracefully degrading if that's the case. So if you're in production, here's an example where the API key was null, the developer shipped Fabric out without it. Unfortunate, Fabric can't run, but we don't want to block all of their users from using that functionality since Fabric is secondary functionality for them most of the time. So if we're not in a debuggable state, then we're just going to return null. We won't start Fabric up. That's unfortunate, but it's not the end of the world. The users still get a good user experience. Your SDK usually doesn't have the same luxuries as an application. You don't get to really pick and choose your devices. You don't get to choose your API levels or your customers. So as an SDK developer, you need to provide maximum flexibility so the developer never has to make trade-offs when deciding on your library versus a competitor. You ever checked out a library or an app in Google Play and thought to yourself, why does this flashlight app need to modify the contents of my USB storage? Permissions are powerful and they allow you to integrate deeply in the OS, but they can seem really scary to users who don't understand what's going on with them or how you're using them. And if they're added after the first launch of your application, it can break auto updates as well, causing a really long tail for that next update cycle. In general, apps and libraries especially should limit the number of permissions they require. Fabric requires just the internet permission, and we then provide hooks so the developer can set extra information they may have collected by using other permissions, but we don't require it. So if our SDK wanted to capture the user's email, we need to have a scary permission like get accounts, which your application would have to declare, and your users might be concerned about since they don't know what's actually going on with this thing.
So we provide a hook, like I mentioned earlier, set user email, so the developer can require the permission if it's that important to them, and then set this on Crashlytics, and it will be available to see in the web dashboard. So with that in mind, though, the developer can set different permissions, and you can have better functionality if that permission exists without requiring it by using permission detection. Here's an example where we're not going to upload crashes to our backend if we don't have network state, but network state requires the permission for access network state. And so we'll check that using the context. And if we get a success back, then we can go ahead and we know that we know what the network state is, we know if it's connected or not, and we can go ahead and perform the upload. But since that permission is optional, we need to have a sane default for this. And that is, we always try to upload if the permission isn't available, because we wouldn't know otherwise, and we'll just get that error in the network stack instead. Like permissions, though, features are another powerful aspect of Android manifests. If you were building a camera app, you might be tempted to define the feature for camera and not see that there's a required flag that's optional. If you do that, then Google Play filters this app on devices that just have cameras. But what if you had a tablet with no camera, and this was a social, with no hardware, and your app was a social camera app like Instagram, where you could browse photos, you could upload them. Instead, you should add this flag, and you can specify that it's not required. And then in your code, you can detect if the camera actually exists, and if it does, you can allow them to that functionality to access the camera. If not, you can block that out in the UI and not let them get to that part. Another important part of runtime detection is being able to figure out what version of Android you're running on. This is probably common sense for most of you, but things like build.hardware wasn't available before Froyo, and so if I had an SDK or a library or an application that was calling this and it didn't get caught, this could cause a runtime error if it launched on a device prior to that. Detecting something like speech detection is a little bit harder. It doesn't require a specific Android version or a piece of hardware. It requires a service that's running on the device. So there's a couple approaches to solving that. One is you can just try to start an activity with that service in mind, and then if the activity is not found, there's an exception thrown. You know that you don't have that. A more elegant approach I prefer is to use the package manager to query for activities that would support this action. And then if your activity list is greater than 0, you have something on the device that can handle speech detection, and you can safely move forward. When providing SDKs to your developers, it's really tempting to use awesome new libraries like OKHTTP or RxJava. But you really don't want to add third-party dependencies in lightweight libraries. I'll talk about that a little bit later. But in this example, what we do is we want to use OKHTTP. It's a great networking stack if it exists. And developers want us to be using OKHTTP when we make all of their requests to the Twitter endpoints or the Crashlytics endpoints. So what we do is we use the provided scope in Gradle, or if you're using Maven, you can use the optional flag. And then we have methods that we do runtime detection, looking for the class path. If that exists, then we know that OKHTTP exists. The developer has defined it as compile. We've just defined it as provided. So it actually requires the consumer of your SDK to specify compile, but they may be using it for another reason already, and we're just trying to piggyback on their choice to use it. And so then here's an example in the Twitter API client. If we have OKHTTP on the class path, then we can go ahead and use the OKHTTP client for all connections. And if we don't, we can fall back safely to the URL connection client, which is just an implementation of Android's URL connection. It's important that developers that include your SDK can use it with their standard testing tools. They don't want your SDK making network requests every time a unit test is run. And you probably don't either. Your back-end engineers aren't going to be your friends if that's the case. And so you really want to make sure that your functionality is tested, that they can test it in running unit tests and mock those sort of things. And there's some tricks to making your SDKs testable, and really I mostly mean mockable in this case. A mock class is just a dummy class that represents and has no ops for the method calls and allows for various types of validations, and you can specify return types from these methods so that you can test them appropriately. And with that in mind, I think that it's really important to avoid static methods in helping with with mocking and testing. Since mocking happens on the instance variable or on the instance method, the static methods are going to get their default behavior, and so that's not as testable. If you're going to be using static methods, they need to be tested in isolation and make sure that your dependencies can be provided up front. Many mocking libraries have problems with final classes, so I'd recommend avoiding those as well. Mockito is a prime example that doesn't like final classes. I think PowerMock can handle them, but it's kind of hit or miss. Public fields also aren't accessible on your mocked classes, so everything should be running through an accessor. Utilize interfaces as much as possible around your public APIs. It's much easier to set up classes to test if your entry points use interfaces. They'd allow a developer to override behavior quickly and set up mock servers or in-memory stores instead of real expensive operations that could potentially be inconsistent. Lastly, avoid mocking more than one level deep. It gets pretty challenging to set up unit tests if you have to provide a mock object and then say, when I ask for this certain behavior, provide another mock object, and when it acts, it needs another mock object. If you've ever tried to do any mocking around context and resources on Android, you'll know what I'm talking about here. So this class represents some of the things that I just talked about that I think make it a little harder to test. It's final, it's a singleton. It's pretty common in Java though, the singleton pattern, but it's kind of an anti-pattern, and it makes testing pretty challenging, especially in isolation. So what could we change to make this testable? Instead, I recommend making it just an instance class, and the developer can reuse or cache this when they need. You're not worrying about the single use. If you remove the final modifier, then Mockito can safely mock this. And also allow the network to be passed in as well. This allows the developer to mock the network so that you're not actually hitting the real network, and they can return the results that are needed. Dependency injection really isn't just a framework like I talked about earlier. It's a design pattern. By taking this sort of thing up front, it helps you organize your code better around testing. Okay, we talked a little bit about powerful SDKs, the importance of ease of integration, the extensibility of the API, handling failure, runtime detection, and making it testable. So next, let's talk about making an SDK lightweight. During the building process for Fabric, we learned a lot of things about this, and these are really applicable to all apps, libraries, and SDKs. So let's keep these in mind. Some of the things we're talking about are binary size, watching out for the Dalvik method counts, limiting network usage, encouraging modularity, and optimizing for startup time. Users are a lot less likely to download a big app. This means that the binary size matters a lot. Unlimited data plans have come in and out of fashion over time, and many users around the world even pay per kilobyte. This is especially true in emerging markets. Also in emerging markets, much of the time the cell connectivity is too slow to download a large app. So there are some great third-party libraries out there that can really contribute a lot to your app, but they aren't free when it comes to the size and impact on the user's application. For Crashlytics, our crash reporting backend uses protobuf. And protobuf, for those who aren't familiar, is just a binary serialization protocol that creates small data objects for efficient transfer to the web service. The Java library for protobuf added over 700K to our SDK, which is significantly larger than the SDK is today. We didn't need all that functionality from the library, so we decided to rewrite the part of it that we needed ourselves before the time of Wire or Nano or other lightweight protobuf libraries existed. The original protobuf was 700K, like I said, and when we decided to just implement our piece of it, we got it down to 10K in Crashlytics. So it was a savings that was worth it, even though it took a lot of time, because just look at the numbers. It's obvious, and when other app developers are making these sort of decisions with your library, you wouldn't want them to choose a competitor because yours is just too large. There's a really easy weight loss hack that focuses on data collection. If you just weigh yourself every day, you will lose weight. You'll start subconsciously monitoring what you're consuming. We take this approach to our SDKs as well. We actively monitor them on each build, and we report this. And we can weigh the true impact against the developer's APK, and we can graph this over time. There are no hard and fast rules around size increases, but it's generally helpful to know how a specific commit increased the size of your library and investigate if that was with or without warrant. Has anyone in here run into the Dalvik 65K limit before? A few of you. And if this was, before the time of multi-dex, it was a little more challenging to solve. Now you can, for those of you who aren't familiar with it, it's a finite limit on the number of method invocations allowed to be referenced by a single dex file. It surfaces when the dex tool tries to write all the method references in a single spot in memory, and there's not enough allocated for it, and it fails. So now you can use multi-dex, and that's great. It works. But it does seem to increase the first app launch when it loads into memory, and it's not really suitable for all users outside of the newest Gradle users. I think a lot of you, if you ran into it before the time of multi-text, you're going to do what a lot of people do, and that's you start looking at your use of third-party libraries and how you can start refactoring and re-architecting your app to remove code bloat. And this sort of SDK audit is pretty common. You don't want your SDK to be pulled out of an app developer's out of a developer's application just because you were too large and they needed something that was a little more modular and lean. We use a great library that was written by an engineer at Quip to track this on each build. If you guys want that, the GitHub link's up at the top. It just allows quick insight into the size from a method count perspective of all the packages for both our SDK and our dependencies. We like the tracking of the sizes. The binary size, we also track this and graph it over time. It's just really helpful to have an insight into where things are getting added. Minimizing network usage is pretty important too. It has the highest impact on battery, one of the highest impacts on battery, and I mentioned the data conscious reasons earlier about paying per kilobyte. So we use protobufs to help with this. Protobuf isn't right for everyone, but they are exceptionally small because they don't include the schema like something like JSON or XML over the wire. With protobuf, it's all compiled down into binary. There's an IDL that the sender and the receiver both agree upon, and that allows for a much faster transfer because it's smaller, and because it's a agreed upon IDL, serialization is much faster as well. So my advice is look into what your needs are. If protobuf's not right for you, Thrift is another similar approach. Compiled JSON could work for you guys. It just depends on the size of the data that you need to transfer. Batching requests is highly important when you're dealing with the radio. This has been talked about a lot, so I'm not going to touch on it too quickly. But if you guys are pinging the radio too frequently, it'll leave the radio in a high-powered state for the majority of the time. It rarely gets into the low power and idle if you are running requests every 20 seconds or so. A naive analytics SDK may just report, hey, I'm in the foreground pretty frequently. Something like this could happen. If you were to batch those requests every 20 seconds into one a minute, you could get much more like the graph on the right over there where you're in the idle and low power state much more frequently. When we started Fabric, a huge concern for us was how we wouldn't provide one giant SDK that had all the functionality that required that everyone had to use. And so we wanted to break this down and make it extremely modular. So we took an approach that used Maven's dependency system so that we could have transitive dependencies. We wanted modularity, and we wanted developers to be able to just say, new Twitter and have all that functionality, but we broke that down by subkits so that a developer who just wanted an embedded tweet or just wanted access to compose tweets without all the underlying functionality could also do that with Fabric. So this is providing choice for the developers. This diagram represents kind of how we architected Fabric. We have one base artifact, which is the Fabric AAR. It has common functionality like caching, persistence, interaction with our web backend, app provisioning, events management, and other things. Then the next level up, we have our Kit common services. So if we're talking about Twitter or Crashlytics, this would be common code that the different feature sets shared. It could be things like specific networking or authentication code for an API that we're dealing with. The next level is more of the user features level. So this is the set of features the developer wants to utilize. This could be things like crash reporting or analytics. And lastly, we have an interface level to bundle all of the features together. This allows for really simple onboarding for a developer who just wants to get started with one line and have everything. But because the stack is built top down, he or she could choose to just use a specific kit and skip the kit interface altogether. Let's see how that works in practice. Here is the stack of Twitter functionality. We have quite a few AARs that are being delivered. If you use the onboarding plugin, then you're just going to get Twitter AAR, and it has transitive dependencies all the way down to fabric.aar. But a developer could choose to use just Tweet UI, for example, and then they would only get Tweet UI, Twitter Core, and Fabric, which would be a much lighter weight solution. And this is just back to being back to providing choice for the developers. How big are the Fabric AARs we talked about? Because we've broken them up like this, we can keep them pretty small. We can keep a lot of the bloat in Fabric itself, which is shared. And then we have a lot of this functionality that's split out that can be really lightweight. And we can share a lot of things like our concurrency system is in Fabric, for example. That way we're not spinning up different threads for each SDK. With Fabric, one of the goals was to reduce our startup time as much as possible, since people are starting this at the beginning of their application launch. And so we do things both synchronously and asynchronously, and we try to get off of the main thread as fast as possible. There are some things that need to happen on the main thread, like installing the crash handler, so that if you have a startup crash, you want to catch that. You don't want to be a user stuck in a boot loop. So we use just executors, and it's important that if you are using these executors that you also set the priority to be background, because if you set the default priority, it's going to be the same priority as on the UI thread, and that can still cause jank. I'd recommend if you guys are building your own SDKs, you think about how you can get off of the main thread as quickly as possible too. Here's an example of the background priority that I just mentioned. I'm going to skip forward a little bit since I'm running a little short on time, I think. So when we were talking about improving startup time in Fabric, I mentioned that we have these shared resources, things like our concurrency system that live in Fabric. All the SDKs share that so that we're not running too many threads. We also do the synchronous and asynchronous initialization that I talked about. It's important for us that we had different priorities for initialization. Some kits needed to be initialized before other kits, so we built this into our thread pool executor. And lastly, we needed a set of dependencies so that we could guarantee that some things ran before others, not just that they were higher priority or lower priority. We built that in as well. These are probably overkill for anything that you guys might be wanting to do for your own SDK or library, but it's important to think about the considerations that you need to make when having an impact on the user's launch time. So we talked about lightweight SDKs, the binary size, keeping an eye on the Dalvik method count, how your network usage counts, how to be as modular as possible, and how to curtail startup time. But there's one other thing that we need to quickly talk about, and that's the support. You've built a really great SDK. It can be used, but if you just put it out there and that's the end of it, you're not going to get a lot of adoption. It's important to think about how you can support your developer community. There's a saying I like. An API is like a baby. They're fun to make, but they take 18 years to support. Any API you add will require a lot of maintenance. I would think about how it affects your roadmap and your architecture choices. Have really clear and concise documentation. This is one of the first points that developers go to learn how to use your SDK. Document every public method and expected use cases. Write concise and simple sample code. People will copy and paste your sample code so much. You don't want to create a full gallery application just to show off a small image loading library. You want to have it as simple as possible so the developer can go in, they can see what's going on, and if they are going to copy and paste it, there's the least chance for bugs. Inevitably, you're going to write your version 1, and it's the first thing you've written, and you think it's amazing. You put it out there, and the internet hates you and your library, and you go home and you cry, and a couple weeks later, you rewatch this presentation, and you wipe away your tears, and you start on version 2. So when this happens, be nice to your developers. Don't just rip out all the methods that you thought were poor design choice from the beginning. Deprecate, mark it as deprecated. Set a clear roadmap for when that will actually be removed so the people that are using it know what's going to happen. And then think really hard about introduction of new public methods, because you're going to have to maintain them for a while. Okay, thanks for coming to learn about how we make lightweight and powerful SDKs. I hope that you guys can take some of these tips and apply them to your own libraries or your applications even. Now I'm available for questions for a couple minutes. Yeah. Yep. Okay. Yeah, so AARs, it's just a type of artifact that can be included in a Maven repo or an Ivy repo or a Gradle repo. Yeah, so if you wanted to use embedded tweets, for example, you would define a dependency in your Gradle script which just says, I depend on the embedded tweets. And then the POM file that's generated, which is the metadata associated with the AAR that lives in the Maven repository, describes what its transitive dependencies are. And so then it knows that it depends on our Twitter core library, and then that knows that it depends on our Fabric library. So for you as a developer, you only ever have the one dependency in your build script, which says the tweet UI. But under the hood, it's pulling down 3 libraries to make that happen. Yep. Yes. The job scheduler would really neither. So that would be your business logic of how you're using that with your networking stack. So you would use OK HTTP to make your network requests, but it's not scheduling when they're going to happen, right? So if you were designing an analytics library, for example, you would need to have your own logic that applied the job scheduler or your own timing mechanism to upload those when it was appropriate. Yep. In the back? Yes, they will be. I'll post them after the talk. Yes. Sure. Regardless, follow semantic versioning so that when you break your API and you know that you made poor decisions and you update it, that's communicated clearly. I would say that communication with your users is extremely important. So if that's the case, then talk about that. Be really reluctant to version that a 1.0. Say, I want to put this out there and I want to get feedback. And then once I have that and this is in a little more stable state, then I'll consider doing a 1.0. That way people are aware it's in the active development state and you're experimenting and you are in that fast velocity state. But as to your point of which things to prioritize, stability is extremely important. If people get a bad taste in their mouth from your SDK even if it's a 1.0, and then later, 2 years later, it's a much later version and it's completely different, they're going to think, yeah, I tried that a couple years ago and it crashed my app and it crashed a bunch of users. I'm not going to look at that again. So stability is pretty important. Yes? Just mobile developers or the entire stack? The Fabric org at Twitter is about 50 people now. And so that's a lot of web engineers, that's infrastructure people, that's iOS engineers, that's Mac app engineers, that's Android developers, that's IDE developers. They're split into feature teams. So I work primarily on the Fabric platform piece, and then I help a lot of other teams build on top of the Fabric AAR and kind of work with architecture and do code reviews and those sort of things. And so that's my piece. And then there are teams that do just the Twitter SDKs that build on top of it. And there's a team that does just the Mopub SDK and the different parts of the Crashlytic SDKs. And those are all distributed pretty evenly. Yep. Yes. Right now, it's under our Twitter terms of service because they're not open source. So there hasn't been a license chosen for that yet. When you're considering your own libraries, if it's open source, like I said, I'd recommend Apache 2. Just fall in line with what Google's doing on Android. MIT would work pretty well also. I'd definitely talk to your legal group at your company or someone who has a little more knowledge on the legal ramifications of those. What's that question? I can't talk about future product stuff, but we're all pretty excited about open source in general. Yep. Yes. Yep. You can. If you look at dev.twitter.com in the documentation, there is use cases there for manual installation as well, where you can apply your own dependencies in Gradle and apply the plugin in Gradle, and then I think you do have to currently provision your app for the first time through the plugin, but after that one process is done, the plugin's not required, the IDE plugin specifically. Because the plugin records build events and it takes your mapping file for our ProGuard and uploads those so that Crashlytics can deobfuscate any stack traces coming in. And it does that every build so that it's seamless to the user. Yes? What is the roadmap for the Twitter API for Fabric? You mean because we don't include all the APIs, so is there a roadmap for the ones that we are going to include? I don't think I can specifically talk about that. Future roadmap and all that. Hold on, let's do a time check real quick. Guys at the back, are we good on time still? Do we have any more? A couple more minutes of question? 3 minutes? Okay, perfect. Yes.
What's your guys' CI setup like for testing? Do you guys test on real devices or
Sure. Sure. It's kind of a mix of things right now. So the Fabric Android SDK gets tested on a cluster of 3 Jenkins boxes that all have moving over to RoboElectric for a lot of our tests as well. So those get run on the JVM level. Then we have nightly builds that run that do a full set of integration tests that hit our backend services as well and do the full integration stack. Yep. Anyone else? Going once, going twice. Cool. Thank you for coming.